Good morning, children. Today we are going to start the chapter Structure of Atom. Now we will just have a basic understanding of how the atom is designed. Now we have studied that atom is the smallest particle which makes matter. What is matter? Whatever you see around you, that is matter. Matter exists in three states: solid, liquid and gas. For example, this table which you see here, the blackboard, all these are solid states of matter. Water, milk, tea, all these are liquid states of matter, and the air around you, that is gaseous form of matter, gas state of matter. In the air you have various gases like oxygen, nitrogen, all these are the gaseous state of matter. Now all this matter is made up of tiny particles called atom. Atom can be defined as the smallest particle which makes matter. All the matter is made up of small particles called atom. Now inside an atom there are three particles. There are three particles inside an atom. First we have the electrons, then we have the protons, and then we have the neutrons. Now electrons are particles which have a mass of 1 by 1857 AMU. Now what is AMU? AMU is a unit of mass. For example, when you go to the vegetable vendor, when you buy potatoes, you ask for 1 kg of potatoes. So 1 is a number and kg is a unit. So a number and a unit together explains the size of the quantity. For example, if I ask you the distance from here to maybe Gandhi Mela, if you say 5 kilometer, you have two things: 5 a number and kilometer, that is a unit. So 5 kilometer consists of two parts: 5 a number, kilometer a unit. Now with the same number 5, if I put meter, it shows another size. Kilometer will show a different size. In the same way, atoms are very small particles, and if we use units like gram to measure the mass of atom, gram will also become a very big unit. So because atoms are so small, we have a special unit for measuring the mass of atoms, which is called AMU, atomic mass unit. Because you measure at the mass of atom and the mass of electron, proton and neutron in this unit, it is called atomic mass unit. So the mass of an electron is very little. Inside the atom you have three particles: electrons, protons, neutrons. Protons and neutrons, they have a mass of 1 AMU each. That is, a proton will have a mass of 1 AMU, a neutron will have a mass of 1 AMU, but an electron is an extremely small particle, almost massless. It has a mass of only 1 by 1857 AMU. Now that is the mass part. The second thing which you have to understand is charge. Now, the unit of charge in physics is coulomb, but here we don't want to discuss about coulomb. We are just going to take the charge of one electron as -1 and the charge of a proton as +1. Coulombs, the value will be something else, but we are not going into that. We are just taking the charge of an electron as -1 and the charge of a proton as +1. Neutrons, they do not have charge. Now, what is charge? To understand what is charge, you must have seen when you comb your hair, dry hair, then after combing your hair or rubbing a comb on your hair, if you take it to bits of paper, you can see the paper coming out. That is because the comb gets charged. That charge is because of the transfer of electrons. Now, once again, we are studying the structure of atom. Atom consists of three particles: protons, electrons and neutrons. You have seen the solar system. Solar system, in the center you have the sun, and you have planets which are rotating and revolving around it. So you have the sun in the center, and you have a planet rotating and revolving around the sun. So in the same way, when you look inside the atom, it looks somewhat like the solar system. In the center, you have something called nucleus. When you study biology also, when you study cell, the center of the cell is called nucleus. Same way, the center of the atom is also called the nucleus of an atom, the central part of the atom, which consists of protons and neutrons. These two particles are present in the center of an atom. Center of atom. This center of the atom, that is also called nucleus of an atom. So center of the atom is called the nucleus of an atom. It consists of protons and neutrons. The center of atom, that is called the nucleus of the atom, it consists of two particles, protons and neutrons, and the electrons example, if you have a center here, if this is the nucleus of the atom, you have electrons which are rotating and revolving around the center in different shells, different orbits. For example, if you take the solar system, you have the sun and you have Mercury in the first orbit, you have Venus in the second orbit, you have Earth in the third orbit. In the same way, there are different orbits around the shell. Orbit number 1, which is called the K shell or orbit. Then you have the L shell, M shell, N shell. We will be doing it right now. So different shells, and we have electrons rotating and revolving around. So that is the basic. So we study once again likewise the structure of atom. Atom consists of 3 particles. Inside an atom again there are 3 particles. The particles are electrons, protons and neutrons. We have to remember 2 things: the mass of each particle and the charge of each particle. Electrons, they have a very small mass. The unit for mass is called AMU. AMU stands for atomic mass unit. AMU stands for atomic mass unit. The mass of proton and neutron is equal. The mass of a proton is equal to the mass of a neutron. It is 1 AMU equal to 1 AMU. Both are 1 AMU. And the mass of electron is 1 by 1857 AMU. That means if you take a neutron, you divide it, you cut it into 1857 pieces, equal pieces. You take one piece, that is the mass of an electron, negligible. Now we come to the charge part. Electrons have minus charge, protons are plus charge. They are equal. Electrons have minus 1 charge, protons are plus 1. The value 1. Here it is equal, but the charge is opposite. Here electrons have negative charge, electrons have negative charge, protons have positive charge. Neutrons no charge, so they are having 0 charge. It is also called neutral charge. So these are the basics of an atom. Now we will study how an atom looks like. Before studying the different how an atom looks like, we have to understand a few definitions. The first definition is atomic number. That is equal to number of protons. That is equal to number of electrons. So what is atomic number? The definition is atomic number is the number of protons. Atomic number is the keyword. Number of protons present in an atom. For example, let us take an example, oxygen. Oxygen has 8 protons, so we say that the atomic number of oxygen is 8. Sulfur, it has got 16 protons, so we say that the atomic number of sulfur is 16. Chlorine, it has 17 protons, so the atomic number of chlorine will be 17. If the atomic number of chlorine is 17, it means that it has 17 protons. It also means that it has 17 electrons. Because in an atom, very important, remember that the number of protons will always be equal to number of number of electrons, and that is called the atomic number. That is definition number 1. Definition number 2, you have something called mass number. Both are numbers. One is atomic number, one is mass number. Atomic number is the number of protons, and number of protons is equal to number of electrons. So atomic number is the number of protons present in an atom. Mass number is number of protons plus number of neutrons. Or you can say proton plus neutrons. Here it is protons. So atomic number is the number of protons present in an atom. Mass number is the number of protons plus number of neutrons present in an atom. Number of protons P plus N. Now let us now understand. Let us take an atom as an example. We take an atom, suppose we take calcium. Calcium has an atomic number 20 calcium, two numbers are written here, one is 20, one is 40. So guess which is atomic number? Atomic number consists only of protons, mass number consists of protons plus neutrons. So bigger number will always be mass number because it consists of two things, proton plus neutron. So it will be a bigger number. Atomic number will be a smaller number because it consists only of protons. So atomic number is the number of protons present in an atom. Mass number is the number of protons plus neutron. So here bigger number is 40 written on top. So this will be your mass number. And this will be your atomic number. So once again, atomic number, it is the number of protons present in an atom. So when I say that calcium has an atomic number of 20, it means that number of protons is 20. Now when I say mass number is 40, it means protons plus neutrons is 40, because we have studied that mass number is number of protons plus number of neutrons. So P plus N, that is mass number is 40. Out of that, P is 20, so what will be N? Out of 40, this 40, this P is 20. 40 equal to P plus N. Now, P is already given 20, atomic number 20. So what will be N? 40 minus P. So what will be N? N will be mass number minus proton. From the mass number, that is 40, you minus proton, you get neutron. So neutron will be mass number, that is 40 minus 20, that is equal to 20. So you have 20 neutrons, 20 protons, and we have studied that the number of protons is always equal to number of electrons. So 20 proton, that means 20 electrons. Atomic number 20, means number of protons is 20. Number of protons will be equal to number of electrons. So number of proton and electron 20, 20. And what is mass number? Neutron mass number minus, if from mass number if you minus proton, you will get neutron. Mass number is 40. So from this 40 you minus proton, that is 20, you get neutrons 20. So here we have the atom of calcium. While studying writing formula, we have studied about different symbols and balances. Here we have the symbol of calcium, the mass number of calcium, and the atomic number of calcium. Now let us see how this atom will look like. In the center, first we draw a circle in the center. This is the nucleus of calcium. Nucleus, I told you, will consist of two particles. One is proton. How many protons are there? 20 protons. Atomic number 20. So number of protons will be 20. 20 protons. How many neutrons? Neutrons, to find out mass number minus atomic number will give you neutron. From this, when you minus this, you get the number of neutron. Neutron equal to mass number minus protons. That is 40 minus 20. 40 minus 20 is 20. So you have 20 neutron. So proton and neutron are there in the center called nucleus. Now you have shells. First shell is called K shell. Second shell is called L shell. Third shell will be called M. So the first shell, you know K, L, M, N, O, P, Q, R. So first shell K, second shell L, third shell M. You start from the center. When you start counting the shells are always counted from the center. From the center, shell number 1, that is K shell. Shell number 2, that is L shell. Shell number 3, that is M shell. Now if you have one more shell, it will be called N shell. Now let us understand how these electrons will be arranged. Now, for understanding the arrangement of electrons, there is a scheme which is called Bohr-Murray scheme of electronic configuration. Now, one more new definition you have to study. You have to study what is third definition. We have done definition number 1, atomic number, which is the number of protons present in an atom. We have done the second definition, mass number, which is the number of proton plus number of neutrons present in an atom. Here we have one more definition for electronic configuration. It is the arrangement. How you arrange electrons? It is the arrangement of electrons in different shells. You can also use the term, instead of shell, you can also write orbits of an atom. So what is the definition of electronic configuration? It is the arrangement. How you arrange? For example, in the first shell, how many electrons can you put? In the second shell, how many electrons can you put? Third shell, how many electrons can you put? So the number of electrons you put in different shells, that is called the arrangement of shells. So what is electronic configuration? It is the, remember the keyword, arrangement of electrons. What is electronic configuration? It is the arrangement of electrons. How you arrange electrons? Where do you arrange it? In shell number 1, shell number 2, shell number 3. So it is an arrangement of electrons in different shells of them. So remember this definition. I have given you all the notes. So go through the notes, understand this definition. It is an arrangement. For example, in the first shell, you will have 2 electrons. Second shell, you will have 8 electrons. 2, 4, 6, and 8. Third shell, you will again have 2, 4, 6, and 8. And in one more shell, last shell, you will have 2 electrons. So here in calcium, the electronic configuration will be Ca calcium. Electronic configuration will be 2, first shell 2, second shell K shell 2, L shell 8, third shell K, L, M, M shell 8, and last shell N shell 2. So 2, 8, 8, 2, 2, 8, 8, and 2. This is the arrangement of electrons. So this is called electronic configuration. Now you understood what is electronic configuration? It is the arrangement of electrons. 2, 8, 8, 2. What is it? Arrangement. First shell K, 2 electrons. Second shell L, you have 8 electrons. Third shell again M, 8 electrons. And last N, 2 electrons. So it is the arrangement of electrons in different shells of an atom. Now how do we get these numbers? We'll come to that. That is the last topic we'll study today. We get this arrangement by following Bohr-Bury scientist scheme. Bohr-Bury scheme. Scheme means method. Bohr-Bury scheme. What do you mean by scheme? Scheme means method. Bohr-Bury scheme of electronic configuration. Now Bohr-Bury, the first thing what is said is to find the number of electrons, in any shell of an atom we use a formula n square, where n is shell number. Now first formula, to find the number of electrons in any shell of an atom, we use the formula 2n square. Now I am rubbing this, remember which scheme are we following? Bohr-Bury scheme of electronic configuration. The first point, remember the scientists Bohr and Bury. Bohr-Bury scheme of electronic configuration, Siemens method. The first point you have to remember is you use the formula 2n square. What formula are you using to find the number of electrons in each shell? 2n square. For example, if you take the first shell, number of electrons in first shell, 2n square. Because this is shell number 1, this is shell number 1, shell number 2, shell number 3, shell number 4. Shell number 1, how many electrons can you put? 2 into 2n square. What is the value of n? N value is 1. First shell, 2 into 1 square. 2 into 1 square is 1 into 1. So 2 into 1, 2 into 1, 2. What is the number of electrons that can be put in the first shell? Is 2. So you get this value 2. Shell number 1. So you get the value 2. Shell number 1, 2, 3, 4. First shell in n place what will come? 1. So 2n square, 2 into 1 square, 2 into 1 square is 1 into 1, 2 into 1 into 1 is 2. Now second shell. Now we come to the second shell. Second shell, 2n square, the formula will be the same. Now here how do you get? We have 2 into, instead of n, what is the value of n here? 2. You are using the second shell. So 2 into 2 square, 2 into 2 square is 2 into 2, 2 into 2, 4 into 2, 8. So how many electrons do you get here? 8. So now third shell. Third shell again you use the formula 2n square. Third shell. So it will be 3RD. Third shell. 2 into, instead of n's value 2, now it will come to 3. So 3 square is 3 into 3, so that comes to 2 into 3, 6 into 3, 18. Now, in the third shell, how many electrons can be there? In the first shell, you can have 1 electron. In the second, first shell, you have 2 electrons. Second shell, you can have 8. Third shell, how many electrons can be there? 18 electrons can be there. But we have put 8. We'll come to that. Why do we put only 8? Now, last shell, fourth shell, you can have 2 into n square. Now we are finding the number of electrons that can be put in the fourth shell. So fourth shell, 2n square, 2 into 4 square, 2 into 4 square means 2 into 4 into 4. So 2 into 4, 8 into 4 will have 32 here. So here how many electrons can you put in the fourth shell? You can put 32. So first point is covered. How do you find the number of electrons that can be put in any shell? You use the formula 2n square. That was the first point. We use the formula 2n square to find the number of electrons that can be put. You cannot put more than that. You can have less than that. For example, here instead of 18, we are having only 8. Here instead of 32, we are having only 2. So when you use this formula, it means that you cannot put more than that. You can have less than that.